Hey, it's Quick Math Tips, and I'm back with part 3 for the paper 3 higher November 2020 papers. Okay, on the grid, show by shading the region that satisfies all of these inequalities. Now, because these are all bigger than or smaller than and equal to, these are all going to be straight lines, normal lines, okay? So if the signs look like this, they would be dotted lines, but because they look like this, they are going to be straight, normal lines. Okay. First, I'm going to convert these into equals to just to draw out the lines, okay? Y equals to x plus 3 and 2x plus 3y is bigger equals to 6. Now, the line x equals to 0 is going to be the y-axis, so I'm going to draw out a line right here. This here is the line x equals to 0, okay? The line x equals to 2, this is where the x value is 2, so this is my line x equals to 2. I'm going to draw that line out, and I'm going to say this is x equals to 2. Now, I need to draw the line y equals to x plus 3, so for that, I'm going to draw myself a little grid. Y is equal to x plus 3. I'm going to draw a little table for x and y values. So 0, 1, 2, 3. When x is 0, 0 plus 3 is 3. When x is 1, 1 plus 3 is 4. 2 plus 3 is 5, and 3 plus 3 is 6. I'm going to plot these coordinates. So 0, 3, 1, 4, 2, 5, and 3, 6. And I'm going to join them up with a ruler, and that's going to be my line. Okay? So this line here represents y equals to x plus 3. Now my last line, 2x plus 3y equals to 6. I'm going to rearrange to make y the subject first. So take away 2x on both sides. 3y is equal to 6 minus 2x. Then I'm going to divide it by 3 on both sides. And I'm left with y is equal to 2 minus 2/3 x. Again, I'm going to create a table for my x and y values. So 0, 1, 2, 3. Now for this you may need to use a calculator, so you're going to do 2 subtract 2/3 times 0, which is 2. 2 take away 2/3 times 1, which is going to be 1.3. 2 take away 2/3 times 2, which is 0.6. And 2 take away 2/3 times 3, which is 0. I don't want to plot the decimals, but I can plot 0, 2, and 3, 0. So 0, 2 is here, and 3, 0 is here. I'm going to join these two dots up to make my line, which is going to look like this. Okay, now I've got my 4 lines. 1, 2, 3, and 4. This one here represents y equals to 2 minus 2/3 x. Now, the next part is shading. Now, if I just want you to have a look at your axes, okay? So these lines, axes. So on the y-axis, if you look above the line, if you're going upwards, the numbers get bigger. If you're looking below the line, if you're coming downwards, they get smaller. And on the x-axis, if you look towards the right-hand side, they get bigger. If you look towards the left-hand side, they get smaller. Okay, this is going to help you figure out what region to shade in. Now, for this one, x is bigger than 0. If the x values are bigger, you look on the right-hand side, okay, because they get bigger on the right-hand side. So we need to look on the right-hand side of this equation, okay? The part that is shaded must be on the right-hand side of that equation. In this one, it says x is smaller, which means it has to be on the left-hand side. So this is x is smaller than 2. It must be on the left-hand side of this equation. Okay, so the shaded region must be on the left-hand side of this equation. This one is y is smaller. If y is smaller, to get the smaller y values, I need to look below the line. So it's going to be below this line here. The shaded region must be below this line. And this one is y is bigger than 2 minus 2/3 x, so it's going to be above the line. So to get bigger y values, you need to go upwards, okay? Sorry. So it's going to be above that line, okay? Now, all of the arrows are facing this direction here, okay? So this is my shaded region, which I will label R, okay? Make sure you do not color in this bit here, because this bit is on the left-hand side of that line. It's very precise, this question, okay? Now, it's not necessarily always the middle, okay? It could be this region, it could be this region. It just depends on where all the arrows are facing, okay? So in this question, all the arrows are facing this one, so this is going to be my region R, all right? Okay, part B, the diagram shows the region S that satisfies all of these inequalities. Jeffrey says that the point with the coordinates 2, 4 doesn't satisfy the inequalities because it doesn't lie in the shaded region. Is he correct? You must give a reason. Now, if the inequalities were bigger than or smaller than, then it would have to be on the inside. However, 2, 4 lies here, which is directly on the line. Now, because it is bigger than or equal to / smaller than or equal to, the points on the line also satisfy the inequalities. So he is not correct. No, because smaller than or equal to and bigger than or equal to includes points on the line. Okay, so it does satisfy. 2, 4 does satisfy as it is equal to as well. Okay, let's move on. Points B, D, E, and F lie on a circle. ABD is the tangent to the circle at B. Find the size of angle ABD. You must give a reason for each stage of your working. Okay, the question is asking us to work out this angle here. First and foremost, this shape is a cyclic quadrilateral, okay? A cyclic quadrilateral is a four-sided shape where all four corners touch the circumference, okay? So it cannot be any other quadrilateral. It has to be a cyclic quadrilateral. Now, my rule is that opposite angles in a cyclic quadrilateral add to 180, okay? Cyclic quadrilateral equal 180 degrees. So I'm going to do 180, take away 100, and I'm going to get 80 degrees. So this angle here is going to be 80 degrees, okay? DBF is going to equal to 80 degrees. Now this shape here is a triangle, and I know angles inside a triangle add up to 180. So I'm going to write that down. Angles inside a triangle equal 180 degrees. So I'm going to do 180, subtract 40, subtract 80, and I'm going to get 60 degrees. Therefore, this angle here is going to be 60 degrees. Last but not least, this angle is going to be the same as that angle because of alternate segment theorem. Okay, this one would be the same as that one, 40, and this one would be the same as that one, 60, because of alternate segment theorem. So I'm going to say ABD is equal to 60 degrees because of alternate segment theorem. Okay, and that's our circle theorem question. Okay, let's move on. Prove algebraically that 0.73 recurring can be written as 11 over 15. So 0.73 recurring, we are going to make that equal to x. Now remember, only the 3 is recurring, okay, not the 7. Okay, so it's going to be 0.733333. We're going to work out 10x, so move the decimal point one place, and it's going to become 7.3 recurring. We are also going to work out 100x, so move the decimal point 2 places, so it's going to become 73.3 recurring. Now I want to cancel out the decimals, so I'm going to do 100x, take away 10x. 100x is equal to 73.3, and 10x is equal to 7.3 recurring. 3 recurring, take away 3 recurring, cancels out the recurring, the going on forever. 73 take away 7 is 66, so I'm left with 66 is equal to 90x. In order to work out x, I will divide it by 90 on both sides, so x equals to 66 divided by 90. Divide the top and bottom by 6, and I'm left with 11 over 15. Therefore, 0.73 is equal to 11 over 15. Because we worked out that 0.73 is equal to x, and x is also equal to 11 over 15. Therefore, they are going to be equal. Okay? Okay. Here is a speed to time graph for a car. Work out an estimate for the distance the car travelled in the first 30 seconds. Now, to work out distance travelled, you need to work out area underneath the graph. So I'm going to work out the area underneath the first 30 seconds. Okay, I'm going to make a triangle, make this into a triangle. And I know my formula for triangle is a half multiplied by base multiplied by height. I'm going to estimate that the height is about 9 and the base is 30. So I'm going to do a half multiplied by 9 multiplied by 30, which is going to give me 135 meters. Okay, so the distance travelled is 135 meters. Is your answer to part 8 an underestimate or an overestimate? Now, what we have done, if you look closely, is we have worked out the area of this triangle. Okay, only the area inside the triangle. We didn't work out this area here. Okay, so we have not worked out the total area underneath the curve because it is a curve. We estimated it to be a triangle, therefore it's going to be an underestimate. Okay, so I'm going to say underestimate. And you have to give a reason, because we did not work out complete area under the graph. We didn't work out complete area under graph. Okay, let's move on. Julian used the graph to answer this question. Work out an estimate for the acceleration of the car at the time 60 seconds. Here is this working. Acceleration is equal to speed divided by time, 13 divided by 60. This does not give a good estimate at the time 60 seconds. Okay, the reason being is what he's done is he went up 60 and he saw that this was 13 and he did 13 divided by 60. Now what he's done is he's worked out an average acceleration of the first 60 seconds. He didn't work out the acceleration at 60 seconds. Okay, he should have drawn a tangent at 60. Should have drawn a tangent at 60 and worked out the gradient of the tangent. Okay? Alright. The histogram gives information about the distances 80 competitors jumped in a long jump competition. Calculate an estimate for the mean distance. So what I'm going to do is we're going to work out how many people each bar represents. Okay, so to do that, I'm going to work out the class width. So 7.2 take away 6.4 is 0.8. 0.8 multiplied by the frequency density, which is 10, is going to be 8. So that bar is worth 8 people. Okay. The next bar is 7.6 take away 7.2, which is 0.4. 0.4 multiplied by 50 is going to give me 20 people. 80 take away 7.6 is 0.4. 0.4 multiplied by 100 is 40. This is representing 40 people. 8.1 take away 80 is 0.1. 0.1 multiplied by 60 is going to give me 12. Sorry, 0.2. 8.2, so that's 0.2. Sorry, 0.2 multiplied by 60 is going to give me 12. Okay, so that bar represents 12 people. If I did 8 plus 20 plus 40 plus 12, I would get 80 people altogether. Okay, now calculate an estimate for the mean distance. To work out estimate, I'm going to get the midpoint of each bar multiplied by the total number of people, then divide it. Okay, I'm going to add these all up. So the midpoint of the first bar is 6.8. I'm going to do 6.8 multiplied by 8. Plus the midpoint of this is 7.4, so plus 7.4 multiplied by 20. The midpoint of this is 7.8, so plus 7.8 multiplied by 40. The midpoint of this is 8.1, so plus 8.1 multiplied by 12. Add these all up and divide it by the total number of people. You could do 8 plus 20 plus 40 plus 12, but in the question it says 80 people, so you can just divide it by 80. I want you to plug this all into your calculator as one big equation, and in your calculator you should get your final answer, which is 7.645 meters, which is the mean distance. Okay, this is the mean distance. All right, follow for the next part. I will start off in part 4 with question 18. Okay, thank you so much.